Yeah, good morning, class, and how are you? Yeah, I hope everybody is fine. Yesterday we had a lecture on the preparation of teaching portfolio, especially in science. And I believe you have gone through the slides and have put down some points that we might discuss at a later time. It's another day. Ghana has recorded 566 COVID-19 cases, and we are still praying and hoping that we'll have or find solution to this problem. So the advice is that stay home and make sure you observe all the protocols laid down by the WHO and our governments. We'll keep reminding ourselves from time to time, but it is important that we see or we attach a lot of seriousness to this situation. Now, our topic for this morning is energy and sources of energy. Energy and sources of energy. Before we proceed, we are still reminding ourselves. So, the protocols for COVID-19, as spelled out by WHO, is what we see on our slide. One, your style of greeting must change. So instead of shaking hands and hugging, you could practice what we have on the screen. At the same time, you are to wash your hands under running water with soap for at least 20 seconds. Use hand sanitizers regularly to disinfect your hands, and also avoid social contact as much as possible. We believe that when these things are properly done, we would kick away COVID-19 in the shortest possible time. Above all, stay at home. Now, energy, as we all know, is very, very important in every person's life. Even for us to be able to defeat COVID-19, we need energy. The sick person on the hospital bed needs energy. And so you realize that the food that we eat will provide enough source of energy for the body. We take in vitamin-rich foods, and this is what the COVID-19 doesn't like. We take in carbohydrates to give us energy, which would urge us on to be able to fight the COVID-19. And so in this era of the pandemic, we are encouraging everybody to eat adequately. Make sure you have enough vitamins, make sure you have enough carbohydrate to give you energy, and eat protein also to be able to build the worn out tissues. Energy is defined as the ability to do it. But before we go through this, we have to look at the general objectives for the topic under discussion. And so for point 1, we are exploring the conceptual understanding of energy as explained by the basic school learner. You know, we are teachers. And when we are done with our course, we'll find ourselves in basic school classrooms. So this concept is supposed to be taught to these basic school pupils or students. And so your understanding of it must be such that you should be able to explain it to these young ones so that they would benefit from it. Again, we are identifying possible energy sources and their socio-economic benefits to Ghana within the environment for use as TLMs. So as I teach, I'll be mentioning some sources of energy that are very familiar in our environment. We see them every day, and that is very, very important because it makes the lesson very interesting. We'll also be looking at the limited supply of fossil fuels and our increasing need for energy. Alternatively, we might fall on solar or other forms of energy or sources of energy which we shall be talking about very soon. And so in the lesson, these things will come out. We are also going to help ourselves to discard the common misconceptions that students and teachers or student teachers have on energy. We will design activities to help us teach the concept of energy to our students. And this, we can find them they are in tandem with the NTS 1B, 2B, 3A, pages 13 and perhaps 14. We also have the others there, 1D, page 12 and 14, and NTS 3E, page 14, NTS 3P, page 14, NTS 1A, page 12. I'm urging you to take your NTS books and read this even as you learn this topic. The core learning outcomes for this lesson are, and they include identifying cross-cutting issues, core and transferable skills, and inclusivity, as well as equity and addressing diversity. We are supposed to be able to do this as teachers so that when we teach, we bring all students on board. Whether the person is visually impaired, whether the person is, physically handicapped, or the person is, okay, we must teach our lesson so that all these students will benefit from it. Again, our course learning or core learning indicators include to role play and demonstrate the concept of energy. You see this in PD Team 1, page 44, and also PD Team 112. We'll be presenting charts on types of energy and also model some uses of energy in everyday life. Again, PD Team 5, page 37. Students, we shall also design activities that can be used to teach energy in a later stage of this course and lesson, and also show simulations of conversion of energy from one form to another. These are to make sure that you understand the concepts and can apply them in future. On the slide that you see, we have various activities being undertaken by human beings. Some walking, some cooking, some dancing, some talking, and some relaxing. Some are also playing hockey and the rest. These are all activities that require or demand the use of energy. For this particular lesson, which will last for at least 1 hour, our objectives are: 1. Define energy and give its units of measurement. 2. We will state two sources of energy, or the two sources of energy, and define each of them with at least 4 examples. We also state the law of conservation of energy and carry out simple energy changes that take place in simple activities of man, including electrical and electronic devices as they function. We also identify at least the common forms of energy and name their sources. So here we will try as much as possible to distinguish between energy source and form of energy, or form of energy and source of energy. We also carry out simple calculation on potential and kinetic energy. So if you are ready, then we can set the ball rolling. Now the question again is, what is energy? And as I earlier on said, energy is the ability to do work. Again, we can also say it is something that a body contains so that it will enable that body to work. For instance, if you eat, the food that you eat gives you energy to be able to do other activities like running, jogging, even singing, dancing, and so on and so forth. A torchlight may require some dry cells or even a battery to enable it to give you the light that you are looking for. The same way, your car or your motorbike may need some fuel, either petrol or diesel, so that it can even start and take you to wherever you want to go. So in short, we will say energy is the ability to do work. Energy is the ability to do work. Now in the first semester, we saw that any quantity that is mentioned in science or in physics has some identity, an attribute that makes us know that actually that is what we are measuring, and we describe this as a unit. So for us to know that what has been measured is energy, then we have to identify it with its unit. And so we all know that the unit of energy, or the standard unit of energy, is the joule. The joule. Joule is spelled with small j, O-U-L-E. The symbol here is capital J. So energy is measured in joules. Formerly, we use a unit called calories. 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 So food contains some energy that can be measured in calories. Now the assignment I'm giving you now is for you to find out the relationship between the joule and the calorie. In fact, find out how many calories will give you 1 joule, or how many joules will give you 1 calorie. And this can easily be found anywhere on the internet. So it's an assignment that I have given to you, and I hope everyone will do that. So we see some gentlemen and women trying to run. They are expending energy. They are using energy to run. Now, having said this, we get energy from various locations, from various places. And so the places or the locations from where we get this energy are described as sources of energy. For instance, we may get, some energy from the sun, and so this becomes a source of energy. So when we say source of energy, then we are referring to places or locations where we can obtain energy. So on your slide, you see that all forms of energy are stored in different ways in the energy source we use every day. That is very important. So examples of the source of energy, as I started with, the sun is a source. We have what we call hydropower. Hydropower refers to moving water. When the water is moving, it has the capacity to cause movement of other bodies. Hence, we say energy is being expended in that regard. And so hydropower becomes a source of energy. We have geothermal. Geothermal. The word geo, which we all know, emanates from rocks. It's a name given to rocks. And then thermal simply refers to heat. And so when we put the two together, geothermal, then what we are simply saying is that it's heat obtained from the rocks or the core of the earth, if we want to put it that way. And so it's expected that when we should dig a hole deep down, we would have some heat coming out of this hole. And then we may classify this as geothermal. We also have tidal and waves. Those of us who have, stayed at the coastal areas, you see that the sea sort of boils, goes and comes back, and this movement of the sea is referred to as the waves. At the same time, sometimes you go there, you have the sea far away, at other times you see it very close. And so we may have a low tide and a high tide, depending on the volume of water in the ocean. We can also talk about biomass, which is actually dry mass of living organisms, biofuels, biogas, gases, fossil fuel, nuclear energy, or a source which we can describe as maybe uranium, because uranium can give us some nuclear energy. So these are the sources of energy that we know of. Again, as teachers, we have to read wide. So even as you find these sources of energy on your slide, it does not stop you from exploring further to find out more if it is possible that we can get other sources of energy other than what we have on our slides. So the ball is in your court. The sources of energy that we have enumerated can be classified into two: the sun, the hydropower, tidal and waves, geothermal, biomass, biofuel, and so on and so forth that we have mentioned. We can classify them into two. And so if you look on your slide, you see source of energy, and we have renewable and non-renewable sources of energy. The renewable source can also be referred to as infinite source, and the non-renewable source referred to as finite source. So we are supposed to look at these two sources of energy and identify the differences between them. Take your pens and your books and brainstorm on renewable and non-renewable sources of energy. Make sure you are able to get at least 5 renewable sources and non-renewable sources. Now, when you are done, then we can proceed and say that the renewable source is a source of energy that is actually in abundance, and so that when you continue using this source of energy, it will never get finished with the passage of time. In fact, constant use of these sources of energy does not lead to their exhaustion, because they are constantly being replaced, and so they will never get finished. So we will simply define renewable source as a source that can be replenished in a short period of time. That is, when you use it, it is replaced, and this cycle continues, so that source of energy will never get finished. The non-renewable source of energy is a source of energy that will get finished with the passage of time when you are constantly using it. So the source of energy is there and we are using it, and by that they will get finished. And because they will get finished, you say they are non-renewable. In fact, we may even say that they are very, very impossible to be replaced or replenished within a short period of time. Again, what I'm trying to say is that these sources of energy, though they can be replenished, it takes longer period of time to get it back so that you can use it again. And so from the sources that we have mentioned, we are going to classify those ones under the renewable and non-renewable sources. We'll go back to our list where we gave some number of sources of energy. These numbers, we are going to classify them under renewable and non-renewable source of energy. So let's go. Now, when you take the non-renewable source of energy, oil, which we obtain from fossil fuels, is one of them. We have coal. Some of us are young and have not seen coal before, but those times when we used the locomotive train, it was the major source of fuel to the train. It comes in the form of charcoal, and this is also obtained from fossil fuel. I'll give you a brief background of the origin of this fossil fuel. We also find natural gas, that which we can even use in cooking. The LPG we have in our homes is a type of gas, but this is also a type of gas. And so this natural gas can be used for cooking as we have the LPG. We also have the nuclear, which is the uranium. And so uranium is a metal or a mineral that we mine, like we mine gold, diamond, and then the rest. But that element, which is the uranium, I believe you remember back at the secondary school where we were looking at radioactivity. Your teachers told you radioactivity is the spontaneous disintegration of radioactive elements to release alpha, beta, and gamma particles. Yes, so exactly what we are talking about. A radioactive material that can disintegrate, and by disintegrating means it splits. And so splitting would lead to releasing of huge amount of energy. In Ghana here, those of us who know of atomic in Accra, we have the atomic energy where the machines there are capable, yes, of using uranium to generate large volumes of, energy, including electricity for us to use. But later on we'll talk about why we have not been able to do that. Now the first three, oil, coal, and natural gas, are non-renewable source of energy obtained from fossil fuel. Now we realize that fossil fuel is obtained from dead organic matter, like animals that have died, plants that have died, and so many other things, human beings inclusive. These things come together and they are buried in the soil and they decay, and when held under pressure over a long period of time, they convert to these fossil fuels, or the oil, the coal, and then the natural gas that we have. Some research has indicated that the oil we find in various places can be linked to some mass deaths, number of people who have died over the years, long ago. In fact, I am tempted to believe that even the oil we have in Ghana is as a result of our slave trade, because many people, died during that period. And so oil is a liquid form of fossil fuel, coal is a solid form of fossil fuel, and then the natural gas is the gaseous form of the fossil fuel. Already I've told you, nuclear reaction from uranium, and I mean uranium is actually a metal that can be mined, like we do for gold and then the rest. So these are the sources of non-renewable energy: oil, coal, natural gas, uranium. And maybe from this lesson, we might also want to look out for other radioactive materials or elements that can also undergo nuclear reaction to give us, the energy that we are talking about. Students, because we have said that non-renewable energy sources can get finished with the passage of time when they are being used, what it means is that we cannot rely on them forever. In fact, they are not sustainable. So sometime to come, or in the near future, the petrol that we have, or the petroleum that we have discovered in Ghana, I mean our crude oil sources, are likely to get finished. And so when they get finished, you and I cannot get our gas to cook our food. We can also not get petrol, we can't get diesel, we cannot get kerosene, paraffin oil, and the likes to do whatever we have been doing with them. This means that we have to look for other sources of energy to rely on in the event that these sources get finished. And this is the renewable source of energy. Yes, the renewable source of energy. Why? Because these sources of energy do not get finished with the passage of time when they are being used. They are replenished within shortest possible time, or within short time. The sun is a renewable source of energy. And it's simple, because since we were born, the sun has been there. It was there during the times of our great-grandfathers and mothers. And it will continue to be there even when we have left this world. So renewable energy, that's the sun, is in abundance. In fact, history and some research has shown that the sun that we have, our sun, which was named by the Romans, has a lifespan. We are told that the lifespan of our sun is supposed to be 5 billion years. 5 billion years. So in the next 5 billion years, the sun will also go and sleep. It will die like we have been dying. The interesting part of it is that 5 billion years is so long, a time. So you can imagine, what we are talking about. Research has also shown that our sun is 5 million years old now. So if you take that 5 million from the 5 billion, then you have about 4.5 billion more years for the sun to die. But it is not interesting, because the sun, like human being, having a life cycle, means that it will grow from young to an adult and become an old man or woman. As the sun grows in age, the temperature on the sun changes. So you may have the red sun changing to a blue and then perhaps go to white. As we have it now, it's red. The red is even fading. And we can link this one to what happens in our homes. You know, when you are cooking in the kitchen, the flame from the stove that is red in nature actually blackens the cooking utensils. It makes them look a little bit black because of what we may describe as incomplete burning. The chemistry people will say incomplete combustion. The sun is not burning properly. Now at the same time in the kitchen, you see you have blue flame when you are cooking. And that one does not blacken your cooking utensils. That is complete burning or complete combustion. So it means when our sun advances to that age and becomes blue, it will produce more heat than we experience today. And that will also mean we may not be able to survive under that particular, heat. And that is why we are being told to make sure we do not deplete the ozone layer. Because when we do so, to that stage, there will be more ultraviolet rays of the sun penetrating or coming through those depleted ozone or the holes, and when you expose your skin to it, it may cause skin cancer. And so even though our sun is a renewable source of energy and has a longer lifespan, it is not a guarantee that we would have it forever. A time will come, it might not even produce heat at all, because it will go to sleep and it will be very cold, and so life will not be possible here. I think that is why scientists are exploring other options, other planets in our solar system to find out if it is possible to have life elsewhere, so that when that time comes, those who will be around will maybe have to flee from the Earth and go to other planets. We can also talk about the wind as a renewable source of energy. The wind. Please Google and find out why we have the wind. In fact, wind is air in motion, okay? So use your search engines to look for why we get the wind, and when you have done this, send your answers to me via WhatsApp or the Google platforms, or even the KNUST virtual classroom platform. So we can use the wind to drive windmills, and this can lead to generation of electricity and the rest. At the same time, we can talk about the geothermal as a renewable source, because the earth is there. It's about digging a hole to get to where the heat will come from. And so when you look at the core of the earth and then the heat that is coming from it, it will tell you that amount of heat will never get finished. Because we are told that the core of the earth is made up of molten, magma. And this is made up of several metals and other things, and they are very, very hot. And so this source will never get finished. We can talk of biomass, that's plants and perhaps animals, dry mass of organic matter. Now, some time back, we used to say biomass, and perhaps, yes, biomass is a non-renewable source of energy, but we now know that we can do cutting down trees and replant them. So each time we cut down one tree, make sure that you plant 100 of those trees, so that constantly we'll have our trees or our plants, and we would have energy in abundance. We may also talk of hydro power, that's running water. And like I said, when you go to Akosomo Dam and then the Bui Dam, which are major sources of electricity for us in Ghana, you realize that the water has been kept at a certain height, and the water is made to run through it, where they have put some turbines, so that by the water running through the turbines, it will turn the turbines, and this will lead to generation of electricity. So it is not just water, but running water, and that is what we refer to as the hydro power. Biofuels, that's fuels obtained from plants and even animals, can be referred to as renewable source of energy because of the earlier explanation that I have given. Biogas, the fecal of human beings, animals. For instance, cow dung, and even when we defecate, these materials can be a very rich source of energy. And so those of us who have heard about biodigesters or biogas digesters and all those things, these fecal matter and cow dung and other things, including those that we get from dead plants, can be used as a source of energy to generate electricity, to generate gas and other forms of energy that we can use in our daily life. Now, having said this, in fact, we were looking at the source of energy. The sun is far away, and you cannot go and carry the sun from where it is to your house. At the same time, the sea is somewhere. You can't go and carry it and bring it to your house. You can't force the wind to blow when you don't have uneven heating of the surfaces of the earth. At the same time, it is not even ideal digging the earth to obtain the heat from it. And so these sources of energy are actually not convenient to use just because they are not portable. And so we will rather tap some energy from these sources, and these energies that we tap are referred to as the forms of energy, because these energies are easily transportable and they are convenient to use. So our definition for forms of energy is simply energy obtained from various sources which are convenient to use and also easily transportable. By saying this, I think you get the idea, and you can even write down some few forms of energy that you know of. So we start with electricity. We can mention heat energy. We can mention chemical energy. We can mention potential energy. We can mention kinetic energy. We can mention light energy, magnetic energy, and many other forms of energy. Now your task is, when you state your form of energy, you should be able to tell us the source from which you obtain that form. I hope I'm communicating. When you tell us that this is a form of energy, for instance, chemical energy, then you should be in a position to tell us where you got it from. That is the source. The source. And so chemical, for instance, can be obtained from food. Substance like tomato, you can get it from other, sources like acids, sulfuric acid, nitric acid, and then the rest. And many other things. Even the food that we eat, they contain chemicals. And not quite long ago, I just mentioned that plants actually produce a source of energy we may refer to as biomass. We also talked about the biofuels and then the biogas. So chemical energy can be obtained from these various sources. That's why I'm saying when you mention the form, you should be able to tell us the source from which we can get the form. So heat is a form of energy. You can also talk of light as a form of energy. You talk of sound as a form of energy. Somebody playing a drum, you get sound from there, blowing trumpets and so on. Sound. Kinetic energy, energy due to movement. So when you are moving, you have kinetic energy. When somebody is moving, or any body that is moving is said to have kinetic energy. So you see a gentleman on a skating board and trying to move. Chemical energy, as I've already explained, can get it from a lot of sources, including chemicals like acids, bases, and salts, and so on and so forth. Electrical energy, interestingly, electrical energy can be obtained from all these sources that we have mentioned. We can get electrical energy from the sun. You can get it from the nuclear, that's uranium. You can get electrical energy from the wind. You can get electrical energy from running water, from geothermal, and many other sources like the geysers and so on and so forth. So if you look at the forms of energy, electrical energy is the most convenient and easily transportable form of energy that is used by all of us. I can have my generator here like we have it in Akosomo, and wires, ordinary wires, have been laid from Akosomo to some substations, and the substations have in turn relayed the wires to our homes, and that is it. You can talk about chemical energy in a dry cell. A dry cell, and we know what a dry cell is. The cells you put in your torchlight, what you normally call battery. Okay, so we can carry them from wherever we want to go to, different places. I can put one in my pocket or in my bag and take it to Accra. Okay, that is chemical energy, and so on and so forth. Magnetic energy, and so on and so forth. We have gravitational energy. Gravitational energy may come in a form of potential energy, which we shall talk about soon. Elastic potential, and so on. So when you stretch a rubber band, okay, the form of energy that even brings you back or brings the band back to its normal, size is a form of energy. That's why you can use that one to, kill a bird on a tree, because you stretch it and then you have given some energy to the stone. So when you release it, it will go and kill the bird perching somewhere, quietly. Even in the use of the bow and arrow, you see that electric potential there. So these are the forms of energy that we have. Remember, I've said that once you mention the form of energy, you should be able to tell us the source, so that these things are not the same, even though sometimes we use the words interchangeably. Now, the forms of energy can also be classified into two. We can classify the forms of energy into two. So, if you talk of the forms of energy, heat energy, light energy, kinetic energy, potential energy, we talked about electrical energy, sound, and so on and so forth. We can classify this into two, and they come under potential and kinetic. Potential and kinetic, or we can say dynamic energy. So on your slide, you see under potential, there are three types of potential energy. We have gravitational potential energy, we have electric potential energy, and we have chemical potential energy. And when we come to the kinetic, forms of energy such as sound, heat, electrical energy, magnetic energy, and perhaps light may be referred to as the kinetic or dynamic forms of energy. Those under potential are supposed to be stored energy which are released when let go. So let's say my marker on the table has some gravitational potential energy. So when I let go of it to fall, that energy will be released. If you walk under a mango tree or maybe coconut tree and one of the coconuts drop or the mango drops on your head, the mango coming from that height has some amount of energy in it. At that height, it has a potential, and that is gravitational potential energy. When it falls on your head, a lot of things can happen to you. Either you forget your name, or you forget what you are doing or where you are going, and by that, it might even kill you. At the same time, elastic, we have just explained that the bow and arrow, the use of the catapult, and so on and so forth. And even chemicals, because when you take the food, the chemicals are actually in the food, they are stored. So you realize that in some science that you have learned, we talked about photosynthesis, then we talk about respiration. During respiration, those chemicals are set free because the energy is in the chemicals. So when you burn the food with the oxygen, then you set the chemicals free and energy is released. That's why we may refer to as that as chemical potential. So again, see the direction that we are going. We have the forms of energy, we have classified them into two, and again we are also saying under each of them, which is potential and kinetic, we can still have gravitational potential energy, elastic potential, chemical potential, all coming under potential energy. And then for the kinetic, we have also listed heat, electrical, magnetic, light, and sound. So this is a question. What form of energy is shown below? If you look at it properly, can you tell me? Write your answer and show it to me. Now we see that this is a coil, and a coil would definitely give you some heat energy. If you look at the heater is a coil. The stove that you use, electric stove, is also a coil. So when electric current is passed through it, because of resistance, it heats up and so generates heat for you to cook your food and so on and so forth. What type of energy is shown below? You have a tomato there. I think we have mentioned it once. So you don't need anybody to tell you that this one is chemical energy. It's very yummy. Again, chemical energy stored in the bonds of molecules. I've explained this already, fuels and so on and so forth. And as I said, even during respiration, the reaction that occurs, the same thing that happens when you mix, let's say, an acid and a base, or mix chemicals. The reaction that takes place is supposed to set some, chemicals free by breaking bonds. And when the bonds are broken, some energy is also released. Photosynthesis, as I've already said, so we have the carbon dioxide plus water, and when the rays of the sun is absorbed by the chlorophyll, food is produced, glucose plus oxygen. The reverse of this reaction is what we refer to as the respiration, which you may look at later. Now, there's a special form of energy which we refer to as the mechanical energy, and this is a form of energy which is made up of potential and kinetic energy. They are obtained from stretched elastic materials and compressed springs. Stretched elastic materials and what? Compressed, springs. And so, if you look at the man with the bow and arrow, he has stretched the bow, and when he releases the arrow, it will go. So by stretching it, there is potential energy there. Release, the bow will move. That is kinetic energy. At the same time, you see a hammer being used to drive some nail into a piece of wood. That activity is mechanical as well. So what do you see here? What type of energy are shown below? Several types or forms of energy. There is electrical, there is mechanical, and there is electromagnetic energy. Please, students, I urge you to investigate this properly. Find out where the electrical energy is coming from, where the mechanical energy is coming from, and where the electromagnetic energy is coming from. This is very important for you as teachers, because you might go to the class and your students would ask you, say, how does the remote functions, and you should be in a position to help the child or the student to understand. Again, you see this man trying to push on a cupboard or a wall, and you see that various forms of energy come into play here. Can somebody tell me, look at it properly and tell me the forms of energy that we have here? I'm sure your answers will be mechanical and thermal energy. Thermal energy here is referring to the heat components of, because when you push the cupboard, it will have to move on the surface, and by moving one surface on the other, heat is generated. I even experienced that when you move your hands, together. So anytime you put something on the floor, you generate some heat energy, and because you are pushing, we'll say that is also mechanical energy. Now, the two forms of mechanical energy, which is the kinetic and potential, we can easily do some calculation on these ones. If you look at kinetic energy, said energy possessed by a body by virtue of its motion. You don't have to chew this definition sacrosanctly. In fact, it's the energy a body has because it is moving. That is kinetic energy. So anybody that is moving has what? Kinetic energy. Now, to calculate the kinetic energy of a body, the formula is very simple. And so we are just saying that Ke, which is kinetic energy, is the same as the mass of the body multiplied by the velocity squared all over 2. This formula is simply telling us that the kinetic energy of a body depends on the mass, okay, which we have learned in first semester. So M is mass, M is equal to mass of that body, and V is velocity, which is synonymous to speed. Okay, we learned that speed is a scalar quantity, velocity is a vector quantity, but then we're using mass times velocity, and you can calculate the kinetic energy of a body. So if, for instance, I'm the one moving, my mass, which you can easily measure using a top arm balance, a beam balance or whatever, you take my mass and you also calculate the distance that I'm covering per the time that I'm taking. That's my speed. And because it will be in a specified direction, we may refer to that as the velocity. And so my mass multiplied by my velocity divided by 2, velocity squared divided by 2, give me the kinetic energy. This, I believe, all of us can do this. So a question to test our understanding of the formula we have just talked about. A bird in a tree was shot and killed by a 50-gram stone fired by a catapult at a speed of 25 meters per second. How much energy was used to kill the bird? A bird in a tree was shot and killed by a 50-gram stone fired by a catapult at a speed of 25 meters per second. How much energy was used to kill the bird? So, I don't know who killed the bird, but all we know is that a bird has been killed, but it was killed with a catapult. So the person has a catapult, put a stone inside the catapult, and then fired. So the concentration on this, as we all know, will be the size of the stone in terms of its mass. And the speed with which the stone moves. Since it's in a specified direction, we are taking that to be the velocity. So our formula says kinetic energy is mass times the velocity squared divided by 2. My mass from the question is 50 grams and my velocity is 25 meters per second. In fact, we have learned in first semester that before you use your parameters to solve a problem, you must make sure that they are in the same system of measurement, the units. So we can see that this gram for the mass has to be changed to what? Yes, kilogram. We change it to kilogram. And we know how to do that by dividing it by 1,000. So probably this one will give us 0.05. Is that correct? 50 divided by 1,000 is 0.05 kilograms. So then we are set to use this to solve the problem. Is this 0.05? Please check on your calculators. 50 divided by 5. if not 50 times 10 to the power minus 3. And that should give us, what do we have? 0.05. So check that and be sure before you start using it. And so with this, then we can say that this kinetic energy is equal to 0.05 multiplied by 25. The velocity is squared, so times 25 again, divided by 2. Please use your calculators to find the answer to this problem, and then let's proceed. Please, when you get your answer, send it to me. I want to be sure that you got the concept right. Potential energy, which is also a form of energy and a mechanical energy, can be calculated using the formula that we have. Now, it is the energy that a body has because of its position, maybe with respect to a certain reference point. So my duster is on the table, and from the table to the ground, it has that ability to fall. So once the duster has the ability to fall, it means it possesses a height, which in this case we are referring to as h. The duster has some mass. You can weigh it. So the mass of the duster is m, and we also learned that any body that is falling under the influence of the force of gravity has an acceleration due to gravity g, which is approximately 10 meters per second squared. So to calculate the potential energy of a body, you need to know the mass of the body, the height of the body, and then the acceleration due to gravity. These are basic calculations that you should be able to do without stress. Yeah, so let's quickly take a question and see how this can be solved. We have a question that says that a stone of mass 0.5 kilograms. So we are told that the mass of the stone is 0.5 kilograms. It has a height, okay, because it was dropped from a height. So height h is 7 meters. We are also told that the acceleration due to gravity, as we've indicated, is equal to 10 meters per second squared. So using this and our formula, P is equal to mass times acceleration due to gravity times height, we can calculate the potential energy of the stone, and the answer must be in joules, because earlier on we said the unit of energy is the joule. The unit of energy is the joule. So students, you should be able to do small calculation on kinetic energy, and then small calculation on potential energy, and then I think you are good to go. Now, energy, as we see it, can never finish. And I'm sure when I said this, somebody in the class is a bit surprised, because earlier on we said that the non-renewable source of energy will get finished. Yes, when they get finished, they change into other forms of energy, which are not the fossil fuels themselves. And so we know that when you have one form of energy, you can change it from one to another form. And that form of energy can also be changed to another form, to another form, to another form, and so on and so forth. So for instance, you realize that when you go and buy your electricity, maybe prepaid or whatever, you slot your card in, what you are getting is light. You put on the light by using the switch, and so electrical energy will change straight to maybe heat energy, and then you have your light energy. Or either way, it's possible. You also have it from electrical to heat direct, and then to light, or electrical to light, and so on. This is telling you that you can't finish the energy in the system, and you can also not destroy it. You can change it from one form to another. And scientists have seen this as a law. So we refer to this as the law of conservation of energy. Energy is always conserved. Okay? It's conserved. You cannot destroy it. You cannot create it too. But you can change it from one form to another. So if I ask you to state the law of conservation of energy, you simply say the total energy in the universe. That's our universe, okay? Okay, yeah. And so if it's the universe, we are referring to it as a closed system. It's closed to other systems. Our universe is closed to other systems. So the total energy in the universe is fixed or is constant and can neither be created nor destroyed. But you can change it from one form to another. Energy can neither be created nor destroyed, can be changed from one form to another. The full law says that the total energy in the closed system is constant. Energy can neither be created nor destroyed, but can be changed from one form to another. And so on our diagram, we see how to show this conservation of energy. If I bring you to my board, we see that this is a fixed point. When you do this, it means a fixed point. And now we have hung a ball. We've hung the ball. As you can see on your slide, this is a ball that has been hung. And so when you take the ball and move it to the right or even to the left, at one point in time you see it here. At another point in time you also see it here. So I mean, it's because it's swinging, it's moving and creating this type of path going up and down, up and down, up and down. So supposing this is our reference point, because this is the height to which this thing can fall, then we see that as it goes from this side to this side, the height is increasing. Good, up to this place. So let's say this is the maximum height it will reach. Again, this place will be the maximum height. At the maximum height when this thing has stopped, because of its position with reference to the ground, it will have maximum potential energy. Maximum potential energy. Then, when it stops, it has maximum potential energy. When it is falling back, that potential energy will be changing to kinetic energy. And so you see that the kinetic energy will also be increasing as the thing approaches the ground. And then it will go to the other side. So this system is just telling us that the energy in the system is conserved, it's fixed. You can only change it from one form. So I am changing it from kinetic to potential, kinetic to potential, and it's like that. And we have other systems that we can think about, like the roller coaster system. We don't have one here in Ghana, but you have to browse the net and get more information on this. So this diagram you see on your slide is just telling us how a body at position E will travel through G, C, D, and E. You want to find out what is happening as the thing travels from E to E. Later on, you may give me answers to that. At E, what do we have there? When it gets to D, what has happened? When it's at C, what do we have? It's at D, what do we have? And at A, what do we have? And this is how energy transformation takes place. In the same diagram we have there, we have this kind of chain. Some chemical energy leading to electrical energy, and your mobile phone is able to give some sound energy, light energy, and heat energy. So if you take your mobile phone, it contains battery. That battery contains chemical energy. The chemical energy will change to electrical energy as a result of some reaction. Then this electrical energy would go through some processes to change to sound, light, and heat energy. This situation is referred to as energy transformation or energy transfer changes. And a lot of it can be found in our everyday life activities. You can see here a turning engine from one form into another. That's energy transfer. What we have there is a car battery. Then this car battery contains chemical energy. Reactions will take place in the car battery, okay? Because the electrode and then the electrolytes. The electrodes are the, how do you call it, the metals in the, but they are those components of the battery that will actually dissolve or react with the solution, that is the electrolytes, to generate the electricity. So here we will have the cathode and then the anode, how do you call it, electrodes. So when they react, they produce electrical energy, which we see in the diagram. And when in a car, this is sent to the plug of the car. Cars contain some plugs, especially those that use the petrol. And so then the car will start because you have turned on the ignition. And when that is done, it generates some amount of heat. The electrical energy reaching the, the plug will generate some amount of heat. Okay, and this is understandable because the energy will pass through, that electrical energy will pass through some wire. The wire will generate the heat as a result of what we have already mentioned. That's the resistance. That heat, when it gets to the plug, because some petrol or whatever fuel would actually come from wherever, then there will be a mixture of heat plus the petrol, and this burns to make the car move or whatever. Your tape will work in the car, and whatever you have in the car will also work. Then you can have the sound coming out from the tape, and the lights of your car will also come on. That's driving in the night. Light is electromagnetic. Then the car can then start moving. And so all these things are just telling you how one form of energy can change to another form of energy. This cycle is, very, very, common with us because we use cars, we sit in cars, and so on and so forth. And we must understand some of these things. Now, to carry out energy transformation or energy transfers, there are some principles that we need to actually, understand. We must understand these principles so that when we are asked what are the energy changes that take place in a given activity. For instance, when a torchlight is switched on or a television is switched on using some electricity from a possible, or maybe a car is, started, and so on and so forth. What are the energy changes that take place? You should be able to tell us. And I'm saying to be able to do that, there are some principles that you have to follow. And these principles are like, first, you must identify the form of energy that will make that activity possible. Identify the form of energy that will make that activity possible. So if I'm pounding fufu, and you want to find out the kind of energy changes that take place, I may be able to pound fufu just because maybe I've eaten. So some chemical energy in food in me is what has given me that energy. Then I will be raising my hands up and down. So that is mechanical energy because it involves potential and kinetic energy. I will be pounding the fufu. As well. But the question is, what starts or what makes it possible for you to pound the food? And that is the form of energy we are looking at as that which makes the activity possible. It initiates the activity. So the first thing you have to consider is to look at what form of energy will make this device work, or what form of energy will make this activity possible. And that should begin the chain. Now, after that form of energy, I'm giving another example. In fact, when you take our bulbs, the bulbs that we use in our homes, in the night we put on our bulbs so we can see dark places. When you want to put on that bulb, if Akosomo or the electricity company takes their light off, it's not possible. So that means that the form of energy that will make the light to work or produce light is electricity, and that is what should start the chain. So the principle says form of energy that will make the activity possible begins the chain. Now followed by some other forms of energy which are intermediary. They actually come between the first form of energy and the last energy you are looking for. For me, when I put on lights, my interest is that the light, or when I put on my bulb, my interest is that the bulb should give me light. And so before I get the light, I need electricity. That electricity, when I put on the light by touching the switch is going to send the electricity through the bulb. And if we take the tungsten filament bulb, what we have been calling onion bulb or jelly bulb, that one, there's a certain element inside. That element is that which glows. It glows, it burns, and by burning then it produces the light. So it means that my electrical energy will now change to heat energy before I get my light. So that heat energy that comes between the electrical energy and then the light energy, we are referring to it as what? An intermediary form of energy. And it is in the middle of the chain. Not necessarily in the middle, but it comes just after the first energy which is making the activity possible. Now the last one has to do with the energy that you need for which you are operating that device or you are performing that activity. So when I put on my TV, my aim is to watch the pictures and listen to sound. That is why I put on the TV. It's not because I want the TV to produce heat. When I put on my bulb, my aim of putting on the bulb is to see light. It's not because I want heat from the bulb. Even though you use the bulb for other purposes like producing light in maybe poultry farm, just to warm your bed. But I'm talking about in your bedroom or your sitting room, when you put on your bulb, the essence of it is to lighten your room so that you can see. Because of that, that should be the form of energy that ends the chain. The third one. So now we have talked about three, set of factors that you have to consider before you actually, carry out your energy transformation. And we said first, form of energy that will make the activity possible. Second, the form of energy that leads to the final activity, which we are calling the intermediary. And now, why that activity is being carried out. In the case of electrical gadgets, the purpose for which they have manufactured that gadget. TV is supposed to give light and sound. If you have a television in your house and all it does is to produce it, go and throw it away, because TVs are not supposed to produce, adequate heat. The same way, if your bulb in your bedroom is producing too much heat, throw it away. You can see why they actually, decided or discouraged us from using the onion bulbs. In the past, when you visit people's homes, you see these onion bulbs all over, the Jerry bulb. But we stopped using them because instead of those bulbs giving us, light, they end up giving us heat. And that will be waste. You are wasting the energy, because that also means that you consume more electricity. And so today we have this fluorescent and fluorescent bulbs. That's the energy saving bulbs, because what they do primarily is to give you what? The light that you need, and that is it. So the end of the chain is the activity that you want to do and for which you have bought that device. Now, all other forms of energy that come after the ones we have mentioned, they are waste. So if I carry out an energy transformation, activity, and for instance, the end results, is accompanied by some other form of energy, in fact, that form of energy will be a waste. I'm giving a typical example. The TV situation. I'll put on the TV through the remote or the switch. Then electrical energy will change to maybe some, electromagnetic energy. I may end up getting, some light and sound. But at the end of the day, the TV becomes hot. So that heat that the TV is producing is a waste. And usually in the chain, we add it as a plus. So plus heat energy. Okay? Now, if we take that of the tungsten filament bulb that I've mentioned, I have the bulb. So electrical energy to, then I'll have heat energy because of the filament there, and I'll have light energy. Now, after the light, the bulb will still become hot. So you can add plus heat energy. All that you are saying is that this heat is a waste. That is not why you put on the light. So all other forms of energy that are not actually supposed to be part of the chain, you regard them as what? Waste, and you add them to the chain using the plus sign. Now if we take maybe a car and its engine. You see that car, that's my car moving. Yeah, a very nice car. The major reason for burning gasoline, which is petrol, in an automobile engine is to convert chemical energy to mechanical energy, kinetic energy to potential energy, radiation to electrical energy, thermal energy to electrical energy. So all these things go on inside the engine. All these things go inside. In fact, the battery of the car plays a major role because it has to initiate these processes that we see here, the battery. So if we were to carry out energy transformation, we start from the car battery, which is the chemical energy. Please, are you following me? Yes. Said always use the arrow to link the chain. So as we have here, electrical energy, heat energy, and light energy, and it goes. But any other form of energy that is not part of the chain should be, added using the plus sign. We also have a boiler, a condenser, a turbine, generator, and maybe some transformer, and then the electricity. So when you have to use heat to produce electricity, that's thermal energy, like what is happening at Abuaze. Heat coming from the boiler goes through some, turbine. The heat is going through the turbine because heat has the ability to move objects. When you are cooking food and the cooking utensil is covered, sometimes when the food inside, especially water inside the container begins to boil, it can even lift up the lid. And so it's telling you that heat has the ability to move objects. And that is work being done. Energy is the ability to do work. So the boiler sends heat into the turbine and turns the turbines, which then leads to generation of electricity. This electricity can be transferred to transformers, which are then, distributed through the power cables to our homes and so on and so forth. And this is another energy transformation that takes place. Please browse the net, look for activities that you are familiar with, and then find out the energy changes that take place in those activities. When you come back, God willing, after COVID-19, we hope to test you on some of these things that we are doing. Now, questions before we end our lecture. Write all the questions you have on this particular lesson and forward it to your course tutors on the various platforms, either on Google platform, on WhatsApp platform, or the Zoom when you have interaction with your teachers, or better still, the KNUST virtual platform. Do so, and we will combine our heads as tutors in the department to give you good answers. So I'm asking a simple question here. Okay, what energy transformation occurs when an electric lamp is turned on? I think we have solved this already. Okay, so you see that there. So here we have electrical energy to electromagnetic energy. No electromagnetic energy may consist of some light, okay? There's light component in there. There's also some heat component in there. In fact, if you look at the radiation from the sun, that's how it looks like. So if you don't want to use that, then you can say from electrical energy to heat energy, then to light energy. So all the terms we are mentioning here, please make frantic efforts to find their meaning and then use them appropriately. Again, this question says, draw a flow map showing the flow of energy transformation in a car from starting vehicle to driving. You should have 5 different types of energy. So some hints have been dropped for you to follow, in ensuring that you can tell us the type of energy transformation taking place when you start a car till when the car begins to move. In our next lecture or lesson, we shall deal with how to teach the concept of energy to our students. So read around this concept. Like I said, we are teachers, and teachers in the making. In fact, we are under training. So one day you also find yourself in a classroom doing what I'm doing here. Okay, I enjoy doing it, and I believe you also enjoy doing same. But when you find yourself in your classroom, you should be able to teach the concept in a manner that your students would understand and use the knowledge they have acquired to help society. That is the essence of education. And so please take note of that. I'm grateful for your attention, and as we have already said, let's stay indoors or stay home and make sure we observe all the protocols spelled out by the World Health Organization and our government, so that we would overcome COVID-19 within the shortest possible time. Good morning or good afternoon.